Hello guys, today we'll discuss a certain type of question, removal and replacement kind of question which comes as part of the section allegation in aptitude examinations. And let's try to find out how to solve this kind of question. From a container, 6 liters of milk was drawn out and was replaced by the water. Again 6 liters of mixture was drawn out and was replaced by the water. Thus the quantity of milk and water in the container after these two operations is 9:16. The quantity of mixture is, so we have to find out what is the initial quantity of mixture. From the question, what we know is 6 liters is being pulled out and then it is replaced by water. So to solve this kind of question, we have a direct formula which says final amount or concentration is equal to initial amount or concentration multiplied by 1 minus y upon x to the power of n. What is y, x and n? Y is amount of solute being replaced, x is the total amount or volume and n is number of replacements. So by now you might have understood this amount of solute that is being replaced is nothing but 6 liters. Whether it is milk or the mixture, it is 6 liters which is being replaced. Replaced with what? Water. So this y is nothing but 6 here. How about x? X is the total amount which we need to find out. We can put it as V here as the total volume or the quantity of mixture. A number of replacements, there are 2 replacements. Once 6 liters is being pulled out and then water is replacing it, and again 6 liters is being pulled out and water is replacing it. So 2 times replacement happens. Now how about the final amount or concentration? In the last status, 9:16 is what is the ratio between milk and water. If milk by water is 9:16, milk upon total is what? 9 upon 9 plus 16, which is 9 upon 25. So this is the final concentration, 9 upon 25. Now what is the initial concentration? If you read the sentence carefully, 6 liters is being pulled out, but what is this 6 liters? Milk is being pulled out. So the initial mixture is actually a pure solution, or you can see pure milk solution. So 100% milk is there, and that's why 6 liters is being pulled out. Had it been some mixture, it would have been a different case. Second hint that is given is the second sentence which says 6 liters of mixture was drawn. So here 6 liters of milk was drawn, here 6 liters of mixture was drawn. Why is the difference? Because once milk is pulled out, once milk is drawn out and it is replaced with water, the resultant mixture has some milk and some water. Now it has become a mixture, and that's why the question says now 6 liters of mixture was drawn out. So initial concentration, from this we can be sure that it's a pure milk. So 100% concentration, 100% is nothing but 1 by 1. So 1 is the concentration that was initially there, and then 1 minus y is given as 6, amount of solute being replaced 6 liters, either it is milk or mixture, it is 6 liters, and v is the volume, total volume. Now what is n? N is 2. N is 2. This n is 2 here. 9 upon 25 is nothing but 3 upon 5 square, and this is equal to 1 minus 6 upon v whole square. So from this we know 3 upon 5 is 1 minus 6 by v or 6 by V is equal to 2 by 5. V comes out to be 15 and this should be the answer. Let us try to find out how this expression fits in, and that solves our question. To explain that, let us assume a hypothetical scenario where 80 liters of solution is present. You can take it to be milk solution, pure milk solution. Now what is the operation we are doing? We are doing this operation. We are taking out 8 liters of this mixture and we are replacing it with 8 liters of water. 8 liters of mixture we are taking out and 8 liters of water we are putting in. So we do it 2 times. What is the final amount of milk which is present? What is the final amount of milk that is present in the solution after 2 replacements? So 80 is the initial case. Once you take out 8 liters, initially this is pure milk, so 8 liters whatever you pull out or draw out is milk. If you draw out 8 liters, it is entirely milk, so you will have 72 liters of milk left. And then you put in water there, 8 liters of water, 8 liters of water. Once you put in water, it becomes again 80 liters. This is the first thing to note. Second thing to note is this 72 is when 8 liters is being drawn out from 80. 72 can be thought of in this way also. You draw out 8 liters out of 80 liters. That means 8 liters is nothing but 1/10 of the original solution. Whatever is the solution, 1/10 of that is 8 liters. If you take out 1/10 of the solution or you take out 1/10 of anything, what remains is 9 by 10. 9/10 remains. So if it was initially 80, 9 by 10 of the solution remains, and this is nothing but this is what 72 is. So after one such replacement, milk is this much, and then you replace those 8 liters with water, so it becomes 80 liters again, and this time it is a mixture with milk and water in the ratio of 9:1. 72:8 is 9:1. Now again you draw out 8 liters. In this 8 liters you will have some milk component and water component. Why? Because after the first replacement, this 80 liters has become a homogeneous mixture. You cannot take out milk and water, you cannot separate out milk and water, but then you know the ratio, which is 9:1 after the first replacement. This 8 liters of water which is next drawn out in the second round will have some milk and some water. So how much milk and how much water? 8 liters is nothing but again 1/10 of the original solution, that is 80. 1/10 of original solution is being drawn out. In that 1/10 will be milk and 1/10 will be water. If you take out 1/10 amount of milk and if you take out 1/10 amount of water, you will get 9 by 10 of whatever was the initial amount. So after first replacement it is 80 into 9 by 10. After second replacement it will be 9 upon 10th of 80 into 9 by 10. We are only interested in finding out what is the amount of milk, because after this second replacement water is put in, so there will be some more water here. The concentration of milk in the first scenario is 100%, and then it gets diluted because you mix in 8 liters of water. It it is diluted, and you replace again 8 liters with milk, it is further diluted. So final concentration can be thought of in this way, a final amount. So final amount F will be equal to what is the initial amount, or I should say 80 multiplied by 9 by 10 the whole square. If you clearly observe, this is what we had done in the question. 80 is the initial amount, 9/10 can be written as 1 minus 1 by 10. 1 by 10 comes from this ratio, 8 by 80. And 2 is nothing but number of times the replacement happens. 8 by 80 is what? Compare this with the expression that we had written in that other page. I is the initial concentration or amount. Y is the amount of solute which is being replaced. X is the total amount of mixture. And N is nothing but the number of times replacement happen. So this explanation helps us understand the formula which we used in the previous question to solve. So this is that expression which we are talking about. Hope you understand where this expression came from, and we can utilize this expression again to solve this kind of question. So we can take one more question. The second question is a bit straightforward. The ratio of petrol and kerosene in the container is 3:2. When 10 liters of the mixture is taken out and is replaced by kerosene, the ratio becomes 2:3. The total quantity of the mixture is... So this question is simpler than the first question, because here the replacement is done only once. The only difference between this and that, other than number of times it is being replaced, is that the initial mixture itself is a mixture of both petrol and kerosene. It is not a pure solution conditions, but in any of the case our formula should be holding good, which says final concentration is equal to initial concentration multiplied by 1 minus y upon x to the power of n, where y is the amount of solute which is being replaced. Y is 10 here, 10 liters is being replaced, and x total amount of mixture or quantity of the mixture is not known. This is what we have to find out. Final concentration and initial concentration. Final concentration, let us think in terms of this solute which is being replaced. Mixture is being 10 liters of mixture is being taken out and kerosene is being replaced. Kerosene is used to replace this. So we'll think about the concentration of petrol. Initially petrol's concentration is 3/5. It is given that petrol is to kerosene is 2/3. So petrol by total solution will be 2/5. Sorry, this is 3:2, so this should be 3/5. 3/5 is the 3/5 is the initial concentration, so I is equal to 3/5. Final concentration is 2/5. 2/5 is the final concentration, equal to 3/5. 1 minus y is nothing but 10, and v is the entire volume. This is straightforward because n is 1. We have 2 by 3 equal to 1 minus 10 by v. 1/3 is equal to 10 by v. V is 30 liters. V is 30 liters.